My name is Principal Singh. I am Professor of Physics. Today we will discuss numericals in kinematics, that is numericals in motion in one dimension. Here is a numerical. A car starts from rest at a constant rate alpha. Then for some time it continues that same acceleration, after which it decelerates at the constant rate beta and then comes to rest again. If the total time elapsed for this whole journey is capital T, then we have to find out two things. The first is maximum velocity attained by the car during the complete motion, and second is the total distance travelled by the car. So first of all we see that, let's say this is the straight line in which car is moving. A is the starting point, and from A to B the car is accelerating at the constant rate alpha. It has started from rest, and then when it reaches point B, the car applies the brakes are applied on the car, and then it starts decelerating, and finally it comes to rest at C. So how to find out the maximum velocity? First of all, when the car is accelerating from rest, its velocity is continuously increasing up to B. Then at point B, brakes are applied and the velocity decreases. So it means that the velocity is maximum at point B. So we have to find out the velocity at point B. For that, let's say time taken from A to B is T1 and from B to C is T2. So now, using the first equation of motion, the initial velocity at A is 0. I will use V equal to U plus AT. The initial velocity at A is 0. The time taken from A to B is T1, and the final velocity at point B is V max, the maximum velocity. So if we apply this, we get the velocity at B is V max equal to 0 plus alpha T1. Now the brakes are applied at point B, and it speeds down, the speed decreases, and it comes to rest at C point. Again I will apply the first equation of motion from B to C. The initial velocity at B is V max and the final velocity at C is 0. So again applying V equal to U plus AT for B to C part. So the final velocity is 0, the velocity at C, the initial velocity is V max, the velocity at B, and the time taken from B to C is T2. So 0 equal to V max minus beta T2, because the deceleration is beta. So we have to put a minus sign here. From here, if I find out T2 equal to V max upon beta, and from this equation it is T1 equal to V max by alpha. Now it is given that the total time elapsed is T. So T equal to T1 plus T2. Now if I put the value of T1 and T2, I get the maximum velocity in terms of the given quantities, that is alpha, beta and T. This is the first answer. Now let's find out the total displacement of the particle, of the car, from A to C. From A to B, it has travelled S1 distance with the acceleration alpha, and then from B to C, it has travelled a distance of S2 with the deceleration beta. So we will apply the third equation of motion, which is V square equal to U square plus 2as, or V square equal to U square minus 2as. The plus is in the case when the car accelerates, and minus is in the case when the car decelerates. So here, initial velocity, this is the initial point from A to B. So the velocity is 0. The velocity at B is V max. So V max square equal to 0 plus twice alpha S1. Now this is AB is equal to S1. The distance travelled is S1. So S1 is equal to V max square upon twice alpha. In the same way, I will apply the third equation from B to C. B is the starting point and C is the ending point. The velocity at C is 0. the velocity at B is V max and the deceleration is beta. So again applying V square equal to U square minus 2S in this case. Why? Because it is deceleration. So it is 0 equal to V max square minus twice beta S2. S2 equal to V max square upon twice beta. If I add these two, S1 and S2, I will get V max square by 2 common under bracket 1 upon alpha plus 1 upon beta, and putting the value of V max from here, we get the distance travelled by the car is half alpha beta upon alpha plus beta into t square. We can do this question by the graphical method also, that is by drawing the velocity time graph. So this is velocity on the y-axis and this is time on the x-axis. The car is starting from rest at constant at alpha. It means that the graph will increase and will come to maximum and then it will decrease. Why? Because the velocity is decreasing. The slope of Vt graph gives us acceleration and this is V max. This is T1 and this is T2. So the slope is V max upon T1 equal to alpha. In the same way, V max upon T2 equal to beta. From here you see that T1 is V max upon alpha and T2 is V max upon beta, just like here. Adding T1 and T2, we'll get again this relation from the graph. And if I find out the area of this triangle, the area of Vt graph, this gives us the displacement, that is half base into height. Base is T1 plus T2 and it is V max. The height of the triangle is V max. Putting this value over here and this is capital T, we will get the result. S is equal to half alpha beta upon alpha plus beta into t square. Thanks.